So we've got a really great presentation today about, I think, the first, and as far as I know, the only developer-led living building project. And we've got Mark Brune and Katie Zabraki. Did I pronounce that right?
Got the Zabraki right.
It's Brune.
Brune.
Oh, sorry. Yeah. Brune. Mark Brune and Katie Zabraki with PAE. And so Mark has over 20 years of experience in mechanical engineering and energy modeling. He's provided design expertise for a wide range of projects from high-rise office to college classroom and laboratory and government buildings. Mark is passionate about helping project teams achieve highly efficient designs through integrated, data-driven design. He is a living future and LEED accredited professional and has provided mechanical design or energy modeling for over 30 LEED rated projects and 5 living buildings. Katie has over a decade of experience developing innovative, energy efficient systems as a mechanical engineer. Her project expertise includes optimizing systems for high performance buildings, designing LEED certified projects, and the newly opened PAE living building. Katie has also significant experience in K-12 design and project management. In addition to being a professional engineer, she has a master's in business administration from Portland State University. She's a valued communicator and brings a collaborative approach to her projects. So thank you, Mark and Katie, for joining us today, and we look forward to your presentation.
All right. Well, good morning or good afternoon, everybody. We're calling in out of Portland. Can you hear me all right now? Audio coming through good?
Yep, you're good.
All right, perfect. Yeah, so we're here today to talk about the PAE living building, which is the building I'm sitting in right now. So it's PAE's home office, developed in, it's in Portland, Oregon. We got done with it last September, so we're closing in on sort of the first year of operation. Yeah, and so just a project we're really proud of. It's targeting full living building certification. We're structuring this as a little bit of a virtual tour of the building, and we'll kind of talk through the developer-led model, some of the the performance characteristics of the building, and hopefully give you a flavor of what it feels like to work inside the space also. Yeah, just a little bit about PAE. PAE is a mechanical, electrical, plumbing, engineering firm. We have a lighting design division, technology, do a lot of modeling and sort of analysis work. About 350 total staff in 5 offices up and down the West Coast. So we're headquartered in Portland in the PAE living building with about 200 people here, and then 2 smaller offices, one in Seattle, one in San Francisco, and then also offices in Eugene, Oregon, and Spokane. And generally, our work tends to be sort of West Coast, except for the right project. A lot of living building projects that we've done have been kind of across the country. We worked on initially the Bullitt Center, then we worked on the Rocky Mountain Institute, which was PETAL certified as a living building in Basalt, Colorado. Worked on the Candida building in Georgia. And then, yeah, just got done with our PA living building office here in Portland. Maybe go on to the next slide. Katie's driving the presentation for us. Yeah, just a little bit more about PAE. We are a just certified organization, so that's an ILFI certification, sort of a transparency label for corporations. I did that a couple of years ago, and then just last year we actually certified also as a B Corporation, just to try and really, from our sort of corporate governance standpoint, make sure that we holistically are, really trying to live a triple bottom line, people, planet, and profit. And yeah, so learning objectives today. Let me see, I can't read that very well from here, but I think, we're going to go over, I'll let you guys read those because I can't read them, but, we are going to focus on.
Yeah, I can hop in here, sorry.
Yeah, perfect.
How to leverage the developer model and create highly sustainable buildings, learn about net zero energy and net zero water and a historic downtown core, understand best practice resilient design in the Pacific Northwest, and explore the life cycle carbon of a living building. So we can follow up afterward about an attendee list if anybody needs to request an AIA credits for this.
Awesome. Thanks, Katie. Yeah, and I think, we've got probably 40 minutes or so of presentation here, and then, Katie and I are happy to take any questions you guys have afterwards. So this is a photo of the building. It's a 58,000 square foot office building, 5 stories. Like I said, designed to full ILFI certification. We're just about to enter our performance period. It takes a long time to get these projects commissioned, and we have a couple of unique systems in here with the water systems and a microgrid that are, we're still trying to get them dialed in. And I think, probably next month we'll start our performance period. 2 other unique things about the building. We tried to think about it on a 500-year life cycle, which is a really long life cycle, especially, for those of us only working here in the United States. Just to kind of put a frame of reference on it, one of the things I think about is I have a lot of family back in Germany. My grandparents actually that I used to spend time with in the summers were in a farmhouse that was built in 1750. So it's approaching 300 years of age already for a building that was built back then. Mass timber building, very similar. And so sometimes I had to kind of remind myself a 500-year life is not completely out of the question for a modern building. It really shouldn't be. And we did a couple of unique things we'll talk about to try and get there to that. And then really important for us was the developer-driven model. There are only about 120, 130 buildings certified through ILFI as living buildings, either fully certified, pedal certified, kind of any of their range of certifications. And so, it's pretty limited uptake, and a lot of those buildings, all of those buildings actually have been privately developed by, either a foundation or maybe a community group, someone that didn't necessarily need to, hit the pro forma of a developer-led model where you bring in investors into a building. And so that was part of what we wanted to do with this was, we wanted to create a full living building. We wanted it as our office, and we wanted to figure out how do we do this in a net positive financial model where we can actually get investors brought in and have them, have a reasonable return on their investment. And so we'll talk a little bit more about how we did that. But it's standing here, so it can be done. Let's move on to the next slide. Yeah, so just Living Building Challenge. I'm guessing probably most of the audience is familiar with it, but we kind of like to think about this as like if the building were a tree on the site. We're in the Pacific Northwest, Doug fir forests are all around us. This was a Doug fir forest until about the early 1800s when everyone sort of moved in and started cutting the trees down. So the forest that was here on our site had to live within the energy budget that of the sunlight that fell on the site. It had to live within the water budget that fell on the site. It had to provide a positive environment for the rest of the ecosystem that was there. And so the Living Building Challenge is really trying to take that model of what does a natural system look like and turn that into our built environment. So that is how we should be building our buildings. So really trying to move beyond sustainable and kind of less bad to an actual regenerative, restorative construction model where what we're doing is actually a net benefit to the environment rather than consumptive. Let's move on to the next one. So there's 7 pedals and 20 imperatives in the Living Building Challenge. You can see all the different pedals and the 20 different imperatives within those. It's performance-based, so you build it to meet these, and then you need to prove that out for the first year of operation, and that's that performance period we're about to enter with our building. So let's start on a tour, kind of moving down to street level. We are in Old Town, Portland. We're at First and Pine. It's within a historic district here in Portland. The buildings across the street from us date to about 1870. Portland itself dates to about 1850. So, really essentially the oldest street, the first street in Portland once Portland became a city. Let's move on. You can kind of see here, this is the site that we have. The site was home to one other building before us. It was the Reed Block. It was built in about 1860, 1870, something like that. Stood there till a little after the turn of the century. This photo, there's a few automobiles in here, it was probably from 1920 or 1930. So you can see the building was still there then. It was torn down, sometime early mid-century, and has since had been a parking lot for basically half of the life of Portland until we developed the site with our office building. And so moving into our building, in our lobby, one of the things that we tried to do was to we wanted to acknowledge the land that was here. We're in Old Town Portland. There's a lot of history of Portland itself here, but like I said, Portland was founded in about 1850, so is around 170 years old. Native American tribes have been here for 12,000 years. So not even a comparison to the blip in time that Portland is. And so we felt that heritage was actually really a more important legacy for the site, and commissioned this piece of art. A man named Toma Villa, he's a native of Portland, part of the Yakima Nation, carved this carving for us. It's about a 7-foot diameter carving of really one of his ancestors coming out of the water. The waves that you can see there represent the Columbia River Gorge and the winds that go through the gorge. And we gave Toma sort of free license. We told him we wanted an acknowledgement that wasn't a plaque, and he came up with this. And the concept was really to honor the traditions that the tribes have with the winds that come through the Columbia River Gorge. There's a lot of renewable energy generation there now. If you drive down the gorge, there's wind turbines all over the place. And he was trying to draw the connection between the renewable energy generation, their traditions, and then this building that's really trying to be about a renewable future. On the back wall, is a basket weave pattern. It's a traditional pattern from the Wasco tribe, which is another tribe in our area here. I don't know if you can see it on the screen, but it's faces, and so faces of ancestors again. And to me, when I think about this building as a 500-year building, I think of it as trying to be a good ancestor. Really, we're trying to build in a way that it creates a positive, a living future for all of our ancestors. And so the lobby really tries to speak to that in the history of the site. I talked a little bit about the net positive financial, or sort of unofficial eighth pedal. And if we click to the next slide, we can get into some of that. So for the developer-led model, there's kind of a 10-10-10 rule that we came up with, trying to explain how we did it. When you're developing a building in a traditional model like this, you're limited by a couple of things. We have PAE was the anchor tenant, so we had a lease rate that we were sort of able to pay and willing to pay. We had a bank loan for this building, and the bank also had a limit on that lease rate as well. So even if PAE had been willing to pay a little bit more, the bank wouldn't underwrite the loan for any more than that. And so what we ended up with is about a 10% premium on our lease rate. Our investors wanted about a 10% return, so 10-10, and then they needed a 10-year hold to get to that 10-year return. And the 10-year hold comes from a couple of things. Part of it is just in the growth of the valuation of the building, and then there's a sale sort of projected in the model at 10 years. And we're also in an opportunity zone here in Portland, and so 10 years maximizes the benefit of that opportunity zone. Some of our larger investors had capital gains that they were able to kind of protect with the opportunity zone. So 10, 10, and 10 is, the sort of secret sauce for us to get this to pay off. And one of the other things about this that we realized, it's interesting is engineers, we don't often come into the early sort of piece of the development discussions, was that the actual price of the building wasn't something that mattered very much. It was really all about the return. So as long as we could raise a little bit more money and the investors still got their 10% return, and our lease rate was within the range that we wanted, the actual price of the building didn't matter. It was a something that went into the formula, but wasn't actually the key to any of it. Yeah, so sorry, yeah, so like I said, how we did it is we were the anchor tenant. We had low interest rates at the time, so that helped us as well. The investor return, at 10% is a decent return. It's not as good as typical real estate investment. So we needed investors that were more sort of, environmental, social governance, ESG investors, that wanted to do this as an impact investment, and really didn't have that much trouble finding that. The opportunity zone I mentioned. And then finally, part of how we did this also was we invested equity from the design, development, and construction team. So, there's a developer's risk when you start to develop a project, as you're paying the soft costs for things. And we used a couple of strategies to sort of mitigate that risk, because our developer wouldn't have been willing to, go into this with, a couple $1 million at risk for all of that. And so we had the landowner developed or invested the land as their investment in the building. And it was a parking lot. It was continuing to sort of generate income while we were doing design. So we had that and didn't have to, pay for the land upfront. It was just an investment in the building. PAE and the rest of the design team, which was ZGF Architects, our contractor, Walsh Construction, our developer, all invested our fees also. So we were paid essentially in shares of the building. So what it meant is that we got nearly all the way through the design phase of the project without having to actually come up with any cash to fund the project. And then once it was going, we saw the return afterwards. And so that kind of helped in this case here, where we had to prove the model, and our developer was interested in doing it, but because it hadn't been done before, skeptical that we'd actually be able to get there all the way to living buildings. So we needed to think about this in a different way to get there. Putting our tenant hat on, so we were investors in the building, we were on the design team, we were also the tenant. How do we justify that 10% premium in rent? And the interesting thing here is, there's a number of different ways, and there's actually one more that isn't on the slide, of how we can justify that. So productivity improvement, if we see a 1% improvement in productivity, we basically break even. By 2%, we're actually to the good on, on the extra rent premium that we're paying. 75% of our cost is in our people. And so, as people are more productive, there's a benefit there. That benefit played out a lot better pre-pandemic. Now with a lot of people working from home, it's a little bit harder to make that case. But I can say working in the building, it is absolutely true. There's a recruiting and retention benefit also. If we can save just a couple percent of staff from leaving, or make it easier to get people in, that also helps pay for it. And we've actually had some staff already who had offers, as everything's kind of shuffling around here post-pandemic, people are getting a lot of offers. And we've had one case already where someone stayed specifically because of this building. So it does have an impact. And then the thing that's not on here is, for us living our corporate values, there's a brand building benefit to that. And so, when I'm talking to my clients about it now, I'm trying to find alignments between, why they want to build a new building for themselves. And, if there's an alignment to their corporate values for living building, or core certification, something like that can really be a strong driver for why you want to do that, because then you can really start to motivate your employees, potentially your clients and customers also, by proving through living your values that you really believe in your corporate values.
Great. Well, I'm going to take over here for a little bit. Thanks, Mark. And kind of continuing on our tour through the building, we're going to head up to the 3rd floor lobby area. This is PAE's main lobby, and there's a couple great features in here that I want to highlight. So first of all, one thing you notice right away, this great desk. So part of the site that Mark was mentioning, there were some street trees that were on the site and were just not going to survive the construction process. So we harvested those and then we're able to have those created into this great piece of furniture for our front desk. You'll also notice this kind of feature wall on the right. If you look closely, you can see sort of an interesting pattern. It's actually the Fibonacci sequence. And so as we page through some of these photos as we tour through, you might see that element reoccurring elsewhere in the building. As part of the biophilia element in the design, we've incorporated not just greenery, not just plants, there's other elements that create biophilic design, and having natural patterns is part of that. And so the Fibonacci series is seen throughout nature, and that was sort of a engineering architectural nod we were really excited to incorporate into the design. Another thing that you'll notice here right away is the beautiful wood grain and exposed ceiling, so or exposed structure. Part of our structure, most of the structure is mass timber, CLT, and we coordinated really intensely early on in the process to create a very clean and open ceiling to really celebrate all of this exposed wood. You can see these light color felt strips running across the ceiling, and those are actually utility chases that we were able to coordinate with our structural engineer, KPFF, and with ZGF, the architect, and then all of our various disciplines to route the majority of our utilities for perpendicular crossings over the structure. So I like to think about it, that upfront time that we spent carefully coordinating really paid off with this simple, clean look that really celebrates the structure. Another thing to point out here, you can see on the back wall, these nice, beautiful, tall windows. So as part of the Living Building Challenge, all regularly occupied spaces have to have access to daylight and operable windows. We have a couple styles of operable windows in our building. The upper windows are actually an awning style window that will actuate open and closed based on temperature differentials between the indoor and outdoor conditions. And then we do have the lower windows. Every other window has a manual operator. So the intent is that we have lots of opportunities for users to engage with their space, have some control of their environment, and interact with this living building. So I'm going to spend just a second here. I was a mechanical engineer on this project, share a little bit about the HVAC system serving this building. I'm sure on the screen you probably can't read all the little text details, but I'm just going to walk you through at a high level how we are heating, cooling, and ventilating our space. So on other projects, we have approached this a little differently, but the developer-led model created some additional criteria around the pro forma. So we got creative early on in our problem solving. So of course, Living Building Challenge, fossil fuel free. So there's no natural gas in the building. All of the heating and cooling is done via air source heat pumps. And so what we have here is on our roof, we have air-cooled condensing units that transfer energy between the ambient air and refrigerant. That's routed down into a refrigerant to water heat pump in our mechanical room. And that transfers energy between the refrigerant and then hot water or chilled water. which is distributed through the building to radiant slabs. So we use radiant slabs to heat and cool the space, and that does the bulk of the heating and cooling. As part of the Living Building Challenge, we have to be able to produce enough energy, 5% more energy than we use annually. So understanding how to reduce energy use was important as an early holistic design discussion with the whole team. So coordinating for a really nice envelope, really reducing loads everywhere, especially the IT loads where when you get to living building standards, IT loads and plug loads end up being fairly dominant in the overall energy use. So we really reduced the loads down and we're able to do most of the heating and cooling with the radiant slab. And then our ventilation is with dedicated outside air units with energy recovery. And those do have supplemental DX coils, so that air is heated and cooled, and that provides some additional heating and cooling for the space. We do have a VRF system that serves our first floor and a couple of our larger, more densely occupied spaces like our large conference room on our third floor. And like I also mentioned, we can take advantage of our actuated windows to passively cool the space or night flush when the conditions are right. So this is another view on our tour, looking kind of from a different angle here at our lobby. Our main conference room is just behind the front desk here, and on the left you can see this beautiful mural. We engaged with a local BIPOC artist to create these murals on each floor that really celebrated a different regional biome in our area. So this floor has kind of a beach or coastal theme and really celebrates these warmer color palettes throughout. You'll see here all of the exposed slab. So that was necessary, that optimizes and allows the slab to be most effective. One of the things that does do is create, it can create some acoustic considerations. So as you kind of peer back into the conference room, we do have some acoustic baffles and lots of felt surfaces to help mitigate some of the acoustics of having an exposed slab and then an exposed ceiling. As we come around through the floor plan, I'll share a couple more details here. All of our office space is basically hoteling. So we engage with an app to select a seat when we're coming into the office, and you can move around day to day. Anybody can sit anywhere in the office. We have no enclosed or private offices, and it allows people the flexibility to find a spot that's going to work for them for that day. They want to be around a project team. The group can select to sit together. They have a lot of heads down focus work. They can select a quieter area of the building, maybe farther away from a break room. And then there's also a thermal component. The south and southeast corners of the building get a lot of sun. They're brighter, and that's appealing to some people. And some people like the northwest corner where we have a few less windows, and it just has a little different environment. So that engagement with the building and that opportunity for choice gives people the chance to self-select what's going to be most productive for them and gives them a sense of autonomy that can increase their comfort and engagement. As we move upstairs, this shot here is a great view of the staircase. Part of Living Building Challenge is we want to encourage a human-powered living. So our interior stair here has some great LED light features in it that engage with the occupants as they use the stairs. So over the course of the day, as more people take the stairs, the LEDs actually have a color saturation that increases. So you can see, oh, busy day in the building, lots of people walking between floors, and you can see that changing over the course of the day. All right, now we're up on the 5th floor, and just to back up for a second, the building is 5 stories, and PAE is a tenant fully on 3 and 5, and then we partially are a tenant on 4 with some sublease space. So we are now up on the 5th floor, which is the upper floor. You can see a little bit more of that Fibonacci sequence that I mentioned before. And this is entering into a really special space in the building that we've called the Decany. It's essentially a multi-purpose room that is available for PAE and some of our other tenants. And it's a great area that is for informal meeting. It has a break room area. We have some taps over there for after work happy hour if we want, and go fully into this space. And one of the really beautiful features here is this large nano wall installation. So as we were designing the building, a feature we have in a few of our other past leased buildings was a roof deck or a really great outdoor space. And with this being a developer-led project and considering some of the other living building challenge requirements, we really couldn't justify carving out any roof space and taking potential solar generation area away. And then as we were looking at the idea of balconies or something like that, there was really no way that was going to pencil out carving out any leasable square footage from the building. So by utilizing this this strategy with the nano walls, we've created a really wonderful indoor outdoor space. So when the windows are fully open, this portion of the building has great views. We have our urban agriculture imperative reflected here. So we have kind of a small crop of fruits and vegetables and other herbs and things that people are welcome to pick. And then it just creates a really great connection with the outdoors. You can see a little bit more of that acoustic baffling here because we do have a large screen in the space for presentations. And so we wanted to be mindful of the acoustics in the space. So one kind of interesting note with this screen, with all of the natural light, it's actually very difficult to get a projector that would effectively work in this type of environment. So we actually went to this tiled screen approach, and it visually works much better than a projector, and it was a fraction of the energy use. So it helped us manage the loads in the space and kind of live within our HVAC capacity budget. So as we peek up on the roof, I'll share a little bit about energy story. So we kind of look, and it's actually a really nice, clean roof. You don't see this a whole lot. So one element you'll notice is that all of the PV panels aren't facing the same direction. As we were developing the project and working within some of our historical district constraints, we could have no visible PV, and we had to minimize or we couldn't have visible HVAC equipment. So we had to keep everything as a very low profile. And when we were looking at what that did to the spacing for having all of the panels south facing, we ended up less productive than if we created this east-west articulating pattern. And it was a really kind of eye-opening moment on our team for the analysis piece on how we could actually optimize the production with the space we had available. You'll see in the lower corner there some of the air-cooled condensing units, and at the center, HVAC-wise, we have some fans and a few other small systems. But essentially, it's a very nice, clean roof. This isn't quite all of the PV that we need, and Mark will talk a little bit more about that if you've noticed, hey, I've seen Bullitt Center and others where there's maybe this big hat that's extending beyond the footprint of the building. We'll maybe touch on that here in a bit. But the roof also does another job incredibly important to the building and the Living Building Challenge, is it's the primary source of how we collect all of the water for being used in the building. So I will walk you through this, kind of what happens to a raindrop that falls on the roof of our building. So the rainwater that falls on the roof's collected. We have a 71,000 gallon cistern below the building. That cistern was sized to help us weather through our dry summer months. Portland and the Pacific Northwest have sort of a reputation for being very rainy. It's frequently rainy in the fall, winter, and spring months, but actually in the summer it's very dry, and we go months at a time with getting little to no rainfall. So we had to size our cistern that we could weather that longer dry period and have enough water available to still serve the building. And we sized that not just on a typical year. We looked back at the past 50 years of weather data to ensure we were sizing the system appropriately to handle some more extreme conditions. From there, the rainwater is treated to drinking water standards. So essentially we have our own potable water treatment system. It's like a mini utility. So we're held to all of the same drinking water standards. And this has been the permitting and approval process has actually gone fairly smooth compared with other projects, but this can be one of the bigger challenges as it's still newer to a lot of AHJs, and there's a lot of different folks involved, Department of Health, the local jurisdictions. So that's still in process, but we're just waiting final approval actually to turn on our potable water system officially. From
Yeah,
there,
I think we got our approval yesterday. I just
oh
saw
my
an email
gosh,
come in.
great news!
So
Breaking news.
Soon here. Yep.
From there, that water is distributed through the building to fixtures like sinks, lavatories, showers, and that water is used, and the water that's not consumed then becomes gray water and is captured and stored back in our gray water treatment system. So our gray water treatment system has a textile filter and filters and cleans that water, and then we redistribute that. So this water is now being used for its second time, this gray water. It's distributed to our flush fixtures, our composting toilets, vacuum flush composting toilets, and our waterless urinals. So the waterless urinals, a little of a misnomer, they do periodically flush to ensure the system stays clean and we don't have any crystallization or buildup in our pipes. And then the vacuum flush toilets do use a small amount of water, and it's about 1/10 of a gallon. So if you think of a typical flush fixture, even on the low end, might be 1.1 gallons per flush. This is just a small fraction of that. So this is really one of the innovative pieces for us on the plumbing side, was combining this idea of a vacuum flush system with the composting toilets. It helped us address a few issues that we have come across in other living building projects with pursuing the water pedal. And it allowed us to essentially decouple the system from gravity. Most composting systems really rely on gravity to move material through the system. And this allowed us to have our composts, all of our compost bins in the main mechanical room just tied to a general system, not simply tied to a single fixture. So if one water closet or one toilet gets more use or flush than the others, it doesn't necessarily mean that the overall composting bin system is out of balance. We can equally dose all of the bins, and it really helps from a moisture management perspective, which is critical for composting. The liquid waste then is also from the urinals is diverted and captured in a large underground nutrient recovery tank. So urine and leachate are stored there and then converted into a liquid fertilizer. So we have an on-site fertilizer production system, and this was also really unique. What this was doing was really taking our water system to the next level to be truly closing this nutrient cycle. So we have people coming into the building, engaging, and rather than treating this particular interaction as just waste, as a once through system, and using precious drinking water as a means to convey waste, we're being very smart with our water use, and we're capturing that material and actually turning it into something beneficial. So really leaning into this idea of regenerative and restorative design. So a quick backtrack here onto the PV discussion, and I'm just keeping an eye here. So I mentioned earlier when we were looking at the roof that you might have suspected, hey, is this enough? You mentioned it's a 58,000 square foot 5-story building. Is this enough PV? Well, early in the process, we were trying to get very creative with some of our constraints in the historic district. And what we discovered was there was really not a good way for us to get all the PV we needed onto this building. And our contractor partner, Walsh Construction, mentioned, hey, you know, there's this affordable housing project that's on the same grid that we're working on. What would you think about a partnership? And this was actually really exciting. Portland, like many other cities, has an affordable housing crisis right now. And this partnership took this constraint that was almost a deal breaker for the project and created this really more holistic connection for PAE and the community at large. So what we've done is we have our PV array on our building, which is about 1/3 of the overall PV required to offset 105% of our annual energy use. And then we installed an additional array on the Renaissance Commons building. We donated that PV, so they get the panels and all of the energy that they produce, which is equivalent to about $20,000 a year. And then we keep the renewable energy credits. So at the end of the day, it feels like this constraint created some creative thinking, creative problem solving, and ultimately something greater than the sum of its parts. So have to take you back down to the first floor and take a quick peek into our mechanical room. I like to say it's the mechanical room, but it's somewhat mislabeled because it's mostly a plumbing and electrical room. Our systems for the HVAC side are actually a quite small footprint. And when you have on-site water and wastewater treatment, that equipment's most of what we're seeing in here right now. So on the left side, we have our water treatment system, our potable water treatment. So a 5-in-1 micron filter. We have large black day tanks. Kind of you can see them sort of central in the photo. So when we're producing water, we do it in batches because of all of the testing and kind of stringent requirements to sort of be your own water utility. It doesn't make sense to make it on demand. We'll have it made in batches, and then you know, every week or two refill those day tanks. Kind of looking over to the right, you can see those were our domestic water heaters. We have 2 heat pump domestic water heaters, and that produces all of the domestic hot water for our sinks, lavs, and showers. And what's interesting, and I'll kind of flip back here, there are positioned directly adjacent to this sort of mesh wall area, and that's actually our main MDF tech area. And so we have a heat source there, and the heat pump water heaters are pulling heat from the ambient air in our room. So it was kind of a nice symbiotic relationship between having the water heaters that wanted to absorb the heat and the IT equipment that was rejecting the heat. Kind of moving back through here, the large green tank in the middle is our gray water storage tank. And then the large blue bins in the background are our composting toilet bins. So we have about 20 bins in our building, and the expected kind of timing is that these aren't something that are cleaned out weekly or even monthly. The compost is generally produced more in the 12 to 24 months range. And given the loading of our building, we expect it to be more on the longer end of that. And then, like I mentioned, the HVAC side of things, we have just a small footprint in this room. We have those refrigerant to water heat exchangers, and then a few pumps. And I didn't talk as much about this, but we do have a microgrid, and we have on-site battery storage. So our building does have the capability to island off the grid. And this is essentially 3 Tesla cars worth of batteries, and it can run portions of the building during summer months when we're kind of optimally producing with the on-site PV for up to 100 days. So now Mark will kind of jump back into some of the performance details.
Yep, and I see we got about 10 minutes left. So let's go back to that last slide. Just 1 second here, Katie. One other thing, I had mentioned the 500-year building, and I think this is a good slide to see this on. So when we thought about 500 years, as a performance metric for the building, we thought about what might cause a building to have to be torn down. And here in Portland, I think the biggest thing that we were worried about is a seismic event. There's sort of every 300 to 500 years, there tends to be a pretty big earthquake along the Cascadia subduction zone. And so what we did is we designed our building to a Category 4 standard, which is the same standard as a hospital, as a fire station. And it essentially means that our building will survive the Cascadia subduction zone quake when it happens next. And the really interesting thing is that we did this in a way that actually didn't impact the pro forma. So to the point I was making at the beginning of the presentation about the actual price didn't matter as much. It was really what the return was. You can see in this slide that we're built to the lot line. You can see up on the top of the slide, there's a building directly to the west of us. That parking lot on the other side, we don't own that, but we built right up to the lot line on it. And normally you leave a little gap, right, between buildings, and we would have had to leave if we built to Category 2, which was code, about an 8-inch gap, so that when the ground starts to move and the buildings are swaying, that they don't actually connect with each other as they're moving around. And when we went to Category 4, we actually stiffened our core. So our shear walls, that are concrete shear walls, got a little bit stiffer. We built some connections between the shear walls, and our building is going to move less in a quake, which means it won't get as damaged. It also means we could build closer to our lot line. So we're now 4 inches to our neighbor on the west, on the top of the page, or the image there, and 4 inches closer to the north. Times 100-foot lot line, 5 stories, that was about 200 square feet of additional area, which was additional lease rate. You put it through the cap rate. It was about $150,000 worth of cost, and that was what the upgrade actually cost. So it paid for itself basically in the pro forma. I see you standing up here. Do we?
Yeah, you're
got
fine.
about
the next session starts at 1, so we just need that.
Yep. I got 5 slides here, so we'll just rattle through these here. As Katie mentioned, 105% net positive energy is where we need to get to. So we're designed to that, essentially 54% more efficient than code, and then providing that with the solar that we added on our site and offsite. Go to the next one, Katie. Net zero water. On a water efficiency with a vacuum flush toilets, we're about 73% better than code. We capture all of that on site. And so in the end, we'll be 100% net zero water. On the next one, you can see our carbon life cycle. Part of the living building challenge is you have to actually offset your embodied carbon. So we did a full life cycle analysis of the building, looked at where our carbon was, tried to minimize as much as possible, and then offset the rest. So our building is actually starting out as carbon 0 and will be carbon negative as we hopefully overproduce energy over the life of it. On the carbon side, this is a bit of an interesting story. So we're a mass timber building with concrete shear walls. We're about 25% less carbon than if we had built purely with concrete or steel. And the donut, you can see where our carbon actually is. So the gray is concrete still. So that's, and then the blue below it is steel. So half of our emissions are still in concrete and steel. So that's really the low-hanging fruit to look out for on the next one. And yeah, and then just to close out, our building, first cost was $435 a square foot. But if you go to the next one, as I was saying, it's really about the pro forma in the end, and being net positive on that. And that closes us out. We might have a minute for questions still.
Yeah, I think we've
thanks for listening.
A question. Yeah, just a sec here. I'll bring it to you.
Thanks for your presentation. Two quick questions. One is with thermal zoning. So with radiant slabs, and there's a certain sense of permanence to that zoning, but with a developer-led building, tenants could change. So I was wondering what you all did for that. And then also, are you guaranteed the solar resource? Is there like a height limitation to adjacent buildings, or how does that work?
Yeah, I'll start on the solar and then maybe Katie can talk about the radiant, but we're in Old Town. Old Town has a 75-foot height limit. To the south of us is also a 75-foot height limit. And so, our solar resource is protected by that. That was really important to us, and we looked at that early on.
And then, yeah, great question on the slab zoning. So we did, we don't know, can't predict the future, but understanding that tenants can change, we did create pretty granular zoning. So most of the zones are in the few hundred square feet, maybe 300 to 500 square foot in size. And so we did create that with the anticipation that potentially there might be partitions or walls or things added later as tenants change. On the first floor, where we have some retail and more of our back of house spaces, there is no radiant. That is all VRF. Just assuming that turnover or that change could be a little bit higher, and that's just a little bit more flexible in that area. So yeah, it was something that we definitely considered and laid it out in a way that's hopefully fairly flexible for the future as tenants or occupants change over time.
And we just went through a 100-degree heat wave last week, and the radiant worked really well. Super comfortable inside.
All right. Any other questions? We've got another minute. All right.
So it's radiant heating and cooling, correct?
Correct.
You probably don't have the condensation issues that we might have in the south. But I'm just wondering any particular challenges with the radiant cooling?
So we do still have to deal with the latent loads. So like I mentioned, the ventilation air that we have does handle the moisture, the latent loads in the space. For areas like our conference room, where we'd be more densely occupied with lots of people, we do have a VRF fan coil unit, so we can provide more kind of cold, dry air. But we still monitor dew point and moisture accumulation, and kind of we'll have the system reset based on those conditions. But we did do a project in Georgia, and I think the strategy there, Mark, was that increasing the ventilation air, increasing the air to handle kind of any sort of moisture or humidity concerns. Did you have anything?
Yeah, pretty similar. Yeah, the Candida building has a radiant floor just like ours, and yeah, like Katie said, we watch dew point and we reset based on that. We have kind of a belt and suspenders, so we look for condensation, then also as a secondary, if that happens, then we would more quickly reset the temperature. So it hasn't been an issue down there. It's been running for a couple of years now.
And we'll also just mention what we've been observing over the past, heat wave. It wasn't just hot, it was also humid, which is not super common here in our hot summer months. And there was consistently a delta between our radiant water temps and the actual slab temps. So there's some things that we're going to continue to monitor over time. But like Mark said, it did weather that and performed quite well. But I know that's always a concern. The slab won't handle. It's a sensible cooling system, so you do have to pair it with the right amount of air.
Well, Mark and Katie, thank you so much for your time. Thank you for joining us from the West Coast today. And if you guys have any other questions, feel free to reach out to them. We have recorded this session if you would like it as well. All right. Thank you.
Thank you so much.
Yes, thanks. Take care.